In lesson 4.4, we're going to talk about some congruencies between triangles, or in other words, how to show that two triangles are exactly the same size and shape. The first one we're going to talk about is when the three sides of one triangle are congruent to three sides of another triangle. This is called the side-side-side postulate, or abbreviated as SSS. In the top two triangles, you can see that we have markings indicating that they are congruent. So we have one dash and one dash, we have a double dash and a double dash, and we have a triple dash and a triple dash, meaning all three sides are matching up in both triangles. Now, if you want to, you can also do this with numbers rather than markings on the side. So down below, I did the exact same thing, but I used numbers rather than markings. Notice how the 9 on the bottom matches up with the 9 on the bottom, that the 5 on the left side matches up with the 5 on the left side, and of course the 8 on the right side matches up with the 8 on the right side. So whether they use markings or numbers, either way, these two sets of triangles are talking about the postulate called side, side, side. In the second postulate we're going to talk about in this lesson, this is when we have two sets of triangles that are matching up, where there are two sides and also the included angle. So two sides and the included angle. This is called the side, angle, side postulate. Side, angle, side. And what you'll see, if we're looking at the markings, is that we have one marking matching up sides, we have a second marking matching up sides, and we have a third marking that's matching up the angles that are contained within those two sides. Not any of the other two angles will satisfy, it has to be the one in between, or the angle formed by those two sides. Again, I can still do this with numbers rather than markings on the triangle. So if I look at the left side, I see the number 6 matching up with the number 6. There's one side. I see the other side on the bottom, which is 11, matching up with the 11. And lastly, I see the angle that's formed in between them, 47, matching up from both. Again, this is called the side, angle, side postulate. It is showing that these triangles are congruent. Side, angle, side.